Hi guys, this video is basically just to talk through some of the terminology that we're going to be using when we talk about some more complicated functions. So what I'm going to do is just go through what all of these mean. I'd like you to write these definitions down in your book as we go. So first of all, we're going to be looking at reciprocal functions. Now reciprocal functions are fairly simple. The simplest form of reciprocal function is where f of x looks like 1 over x. That's a very simple reciprocal function. A more complicated reciprocal function is where f of x equals 1 over, k over x, where k is some sort of real number. So very simple reciprocal functions. There's a slightly confusing point here next because we also talk about the reciprocal of a function. Now remember, reciprocal basically means 1 over. So if we talk about a reciprocal function, we're talking about 1 over something. If we talk about reciprocal of a function, that's where we actually have 1 over the function. So if we have 1 over f of x, then we can say that 1 over f of x is the reciprocal of f of x. So, for example, if f of x equals x plus 2, the reciprocal of that would be 1 over f of x, which would be 1 over x plus 2. And then this final thing that we're going to be looking at is this idea of a rational function. So a rational function is basically where you've got something like f of x over g of x, where f and g are both polynomials. And I should probably say they're both real polynomials. The reason we call them rational functions is it's a little bit like rational numbers. So you know that rational numbers are numbers that can be written as one number over the other. Say, for example, p over q. If a number can be written in that way, we call it a rational number. A rational function is very similar. A rational function can be written as a real polynomial divided by another real polynomial. So that's just another piece of terminology. And then the last sort of type of function that we're going to be looking at involve absolute values. So absolute values looks very similar to something we've already done with complex numbers. Absolute value functions basically involve the modulus of x, or some sort of function of x. So we could have modulus of f of x. And these two lines basically indicate the absolute value or the modulus. We can also call them modulus, just like we did with complex numbers. And basically what we're talking about here is taking the modulus of a real number. So x or f of x in these cases are real. So the modulus of x or modulus of f of x is the distance from 0 on the number line. And if we remember back to complex numbers, when we talk about the number line, what we're really talking about is the real axes on the argand plane. What this means in practice is that the modulus of x is just going to be equal to x if x is a positive number or 0. And if x is less than 0, it's going to be equal to the negative of x, which will get us to the positive, if that makes sense. For example, if we have the modulus of 3, well, that's just 3. But the modulus of negative 3 is also 3. Okay. One other way of defining the modulus is to use a little mathematical trick. So modulus, or the absolute value of x, is equal to the square root of x all squared. Because the square root will give you a positive or a negative answer, but it doesn't matter either way, because once you square either of those values, you're going to get the positive answer only. So that works as well for generating the absolute value. Okay, so that's just some terminology that you'll need to know going into the first week back. So hopefully that helps. Make sure you've written that down, and we'll all be on the same page. Okay, thanks for watching.